Hello, and welcome to Quantitative Reasoning. We're working in set applications. This is video 3 of 5 for the set applications section. Here we're going to talk about identifying subsets and proper subsets. Subset is something you might be able to figure out what it means just from kind of hearing the word, that kind of thing. Proper subsets probably needs a little more definition. These are, again, definitions that we need to know as we go through in class. We previously noted a universal set contains a complete list of all elements that we consider within the context of a particular problem we're doing. The universal set, if you want to know what days of the week are considered the weekend, the universal set is the days of the week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So if I say weekdays, Monday, Tuesday, Wednesday, Thursday, Friday, is a subset of the days of the week, because every element in set W, the weekdays, also occurs in set U. So W is a subset of U would be one way this is written. And so W, this is the symbol for is a subset of. We could also write W is a proper subset of U. And if you look at this sideways U without the little bar underneath means is a proper subset. That's in your symbol list. If you can write set W is a proper subset of set U, this is also true over here, that it is also just a regular subset of set U. When you think of the word subset, you tend to think something less than the original set. U is the original set. And indeed, we were missing Saturday or Sunday. But it turns out, if I had listed all 7 days of the week and called it set A would be a subset of U. But I wouldn't be able to write proper subset, because to be a proper subset, the set on the left has to have less elements than the set on the right. All of the elements on the left have to be found in the set on the right, but it doesn't contain every single one. You can remember the difference because this equal sign means it can include all of them. Like if you write x is less than or equal to 3 in algebra, it means x can be 3. But if you take out that, it means x can't be 3. It has to be lower than 3. It has to be smaller than. So it's a very similar symbol. The handwriting there isn't great. I apologize for that. All right, so here's the formal definition. A subset of a set U, or any set, is another set that contains only elements from the set U, but may not contain all of the elements of the set U. It may not. It can contain all of the elements of set U, but it doesn't have to contain all of the elements. So this, you look at the set on the left and you decide, is every single set element in the set on the left in the set on the right? You don't have to have the entire set on the right, but you have to be able to find everything in the left by picking from the set on the right. So U doesn't need to be a universal set, is what this is saying to us here. You can talk about the subset of any set. If you wrote a new set A and just said that set was Monday, Tuesday, that set would be a subset of W. And it would also be true that A is a proper subset of W without the equal sign, because there's 2 elements in A, and I can find each of them in W, so that definitely means this is true. And there are some elements in W. There's 5 elements in W and only 2 in A, so it's actually a proper subset because it's smaller. So any set is a subset of itself, but is not a proper subset of itself. So what you could say, if set B, and this should say formally speaking, if set B is Monday, Tuesday, you can say this, A is a subset of B. You could also say B is a subset of A. But you can't take these equal signs off, because B and A are actually equal. We've talked about equal sets, or we will. So that's a subtle thing. If set C only contains Monday, then set C is both a subset of B and a proper subset of B. So this slide gets more technically into the proper subset. So we started with this example where we have set B and set A, and B is a subset of A. And it turns out A is also a subset of B. And if that's true, what you know, if it goes in both directions, you know the sets are equal. But when a subset does not contain all of the elements, we can say it is a proper subset. And I showed you this in the last slide. So this is that same symbol for subset. This is the symbol for subset. That's a U. It's supposed to be a U with a line under it. Without the line, it becomes a proper subset. Now, that's a little confusing because the symbol with two parts has one word and the symbol with one part has two words. But you just need to practice that to get that. So think of the less than or equal sign. 3 is less than 5. But 3 is, you'd have to use less than or equal to 3 for that to be true if they're the same size. But if this number is smaller, then that's true in both cases. You could have the equal sign. But if this number is the same, it's not true without the equal sign. So in subset, always it's rounded off, just like you always point to the smaller set. You always point to the set that could be smaller. The set on the left is the one that is a subset of the one on the right. Keeping the order sometimes gives students difficulty. So here is the full definition of proper subset. If the original set is finite, any of its proper subset will have fewer elements than it does. However, it's infinite. You might have a proper subset that's infinite. We are not going to get into that in this class. We're just going to work with subsets will be finite in this course for the purposes of our discussion. All right, so let's do some practice. Let's consider the following sets. A is 2, 4, 6, 8, and so on out to infinity. So as a way of review, we say that A is an infinite set. B is finite, and it has a cardinality of 3. Its elements are 4, 6, 8. C is finite with a cardinality of 4. So it's 4, 6, 8, 10. And once you know the cardinality of C is larger than the cardinality of B, you know it's impossible for C to be a subset of B, because there's going to be one element that isn't in B. So we're going to use proper notation to indicate which of these three sets are proper subsets of each other. So set A is the set of all positive even integers. That's another way to phrase that list. Meanwhile, both B and C are proper subsets of A. They do contain only even numbers, so everything in B can be found in A, everything in C can be found in A. So, and they don't have all of A. So I can write the B as a subset of A using the proper subset symbol. B is a proper subset of A is how you read this. C is a proper subset of A is how you read that. Now, I could write B as a proper subset of C, but it is not true if I write C as a proper subset of B. That is not true, because I have a 4 and I can find the 4 in B, I can find the 6 in B, I can find the 8 in B, but 10 is not in B, so C cannot be a subset of B. So these are proper subsets because B has a smaller number of elements than A, but every element in B is found in A. C has a smaller number of elements than A, a smaller cardinal number, but every element in C is found in A. And for the cardinal number, just as a notation review, you write n parentheses B equals 3. This n with the parentheses and the set name inside says, give me the cardinal number of that set. That's the notation used in your text for that. Okay, so this looks like the same. No, it's a different set, but it's very similar. A is the set of positive integers, and it's infinite. B is 1, 3, 5. C is 2, 4, 6. So again, B is a proper subset of A, C is a proper subset of A, but B is not a subset of C because there are things in B that are not in C, and you only need one thing to not be in C. And there are things in C not in B. So if B is not a subset of C because it's missing something, then C wouldn't be a subset of B. So, but B is a proper subset of A, and B is also a subset of A. If I write B is a subset using the full symbol for is a subset of A, I have a little trouble drawing that round of A, that would also be true, but more specifically, B is a proper subset of A. Okay, this will be for the next video. So you really just have to keep straight for this part of the, if you only see this, it's a less than. The things on the left have less than the things on the right. The set on the left has less elements than the set on the right, but all the elements on the left are on the right. And if you do this, the set on the left could have less than or could be equal to the set on the right. So a proper subset cannot be equal to the set on the right. A regular subset could be the same set as the set on the right. So that's all for this video. This is part 4, and tune in for part 5, and I'll see you in class.